Hello, today we will solve LeetCode 3074, Apple redistribution into boxes. This is a daily problem on December 23rd. You're given an array apple of size n and array capacity of size m. Basically, you have a number of apples in each element of the array. You have a capacity for each item capacity in the array. Essentially, you can think of these like box sizes, and these are your apples. The idea is the following. We want to select the least amount of boxes to use to store our apples. So in this example, we have 6 apples, so we should probably take this 5, and we can take any other box. Let's say we take this 4, so our output will be 2. The idea for this problem is relatively simple after you understand that you don't actually care about the indexes of this apple array. You just want to know that, okay, you have 6 apples or you have 15 apples. It doesn't matter that the apple in index 0 should go into the box at index 0. That's not true in this case. We should just redistribute them however we want. Then after that, the problem becomes a little more clear. We want to just every time choose the biggest box we have. It's kind of a greedy approach, they call it. And we can do that with a priority queue. Essentially, with a priority queue, if we take a max heap, we will always have the biggest capacity. And so we just keep going until we fill all our apples, and we return the time or the counter of boxes that we've used. So let's actually solve this. I'm going to calculate the sum of the apples. I don't actually care where each apple is, I just want to know how many apples we do have. Now we have the total sum. Now I'm going to initialize a counter. This will actually tell us how many boxes we've used so far. And now I'm going to create a priority queue. You could also solve this problem by sorting, but I think priority queue is the little more simpler approach, even though this does use some extra space. And so here I'm making a priority queue using a max heap. You could also pass in a comparator. You could do something like new priority queue comparator.reverse order, but above I'm using a lambda expression. Makes it a little more simpler. So now I'm going to add every box into our priority queue, so we can always have the biggest box we have at the top. So let's do that. Let's add queue.add I, and now we have a priority queue full of our boxes. Now the idea for calculating how many times we need to use a box is simple. While our sum is greater than 0, we're going to subtract from our sum the top of the priority queue, and we're going to increment our counter. And now we're going to return our counter. Just so you see how this works, we can go over this example. So our sum will be 6, and our priority queue at the top will have this index or this number 5. So we're going to start this while loop, and at the top we're going to pop all 5 and subtract from our sum. Now our sum is 1, and we're going to increment our counter. Our while loop is going to go back up to the top, and we're going to repeat the process, but now at the top is going to be 4, because the property of this priority queue is that we will always have the largest number at the top. Then we're going to do sum minus equals 4, and previously we had 1, so this would be -3. Then we increment our counter, we check our condition, our sum is now no longer greater than 0, so we hit this return counter. So let's run this. This is actually called the apple array. And let's submit that. And you can see it's relatively efficient. Please leave any questions you have down below. And of course, this is a O of m log n solution, where m is the amount of elements in the capacity array. This is the worst case, as adding to a priority queue is log n, and there's m elements.